Hello everybody and welcome to class today for our second live stream. Our second live stream today is going to be focusing on Module 2. I've got a few slides of information for us to look over here, so we're just going to have a quick look at a few slides of information, and then we're going to hop into a development environment and do a quick example program that's just going to cover some of the things, or really pretty much everything that we talk about in this module. So without further delay, let's go ahead and get started. So we are talking about variables, expressions, and statements in Module 2. That's the focus of Module 2. So I want to make sure that you all take some time, read all the material that's there, and kind of, work through it all and make sure that you really understand it. But we're going to just discuss a few of these topics. So let's first talk about what a variable is. So when we're talking about a variable, essentially what we're talking about is a container. So when you're thinking about a variable, when you create a variable, you can kind of think of it as a container, as this empty sort of vessel. And then inside of that vessel, we can put data right into there. And so we name this variable, we give this container a name, and then we fill it with some data. We assign it a value. And what that does is that creates a symbolic relationship between the name of the variable and the data that we put inside. So that way we can also change the values that are inside of the variable to where they can be different things at different times of the program, and our equations and our algorithms and our various things that we code into our program, we don't have to change those. So it gives us that sort of flexibility. Now with Python being weak typed or dynamically typed, we don't have to declare the variable type. So when we are declaring a variable in Python, we declare it and assign it a value all in one go. And when we get to our example in just a moment, we'll be doing some of that. So that's kind of a variable in a nutshell. It's a symbolic relationship that's created between this name of this container that we create and the value that we put into it. And for the time being, it's not that big of a deal. We're kind of creating these static values and putting these static values into our program. But a little later on, when we add some more into our knowledge base about what we can do with programming and how we work with variables and things of that nature, the idea of a variable becomes much, much more important. One of the things that we can do with variables at this point in time is we can use it to work with composition. So when we write a program, we use composition rules. We want to break it down into smaller parts. And in breaking down a program into its smaller parts, this gives us a little bit of flexibility. It gives us a flexibility in multiple different ways. It gives us flexibility in sort of fixing things when there are problems. So because we've broken things down into smaller parts, we can kind of isolate where issues might occur, and then going back to where those issues occur and fixing them at the source, and we can use them to provide information to our user. Because if we kind of break things down into small parts, then we have these small parts still in memory. Now that doesn't mean we need to keep everything in memory, as a variable or stored somewhere. For our example today, we're probably going to go a little overboard with what we keep in memory because we're not going to use everything that we keep in memory. But if we break everything down into smaller parts, then we can share our data in different ways and use our data in different ways. So it gives us more flexibility with how we are able to do things and what we're able to do with the things that we have. So that's one of the reasons why we want to use variables at this point in time. So instead of just putting a big long equation in our output, we can create a variable that has a little piece of an equation in it and then feed it into another part of an equation, and so on and so forth. So what is an expression? An expression is a combination of values, variables, and operators. So we could have something like, if we had a variable that we called n and n plus 7, n plus 7 is an expression. But then a value all by itself is an expression. So just 7 would be an expression. Or a variable all by itself would be an expression. So just n could be an expression. So in this case, all three of these things here are valid expressions. N plus 7, 7 by itself, or n by itself. All are valid expressions. Now when you type in an expression, wherever that expression is in the program, as the interpreter is going through the program, doing its thing, reading the program, wherever that expression is, the interpreter evaluates it. And what that means is that interpreter finds the value of that expression at that point in time. So let's consider this. Let's consider the fact that we have a variable. We have a variable of n, and we've set it equal to 3. So with a variable of n that we've set equal to 3, we can have a few different expressions. We can have n. We can have a number by itself, like 7. And we can have the value of a variable and a value together with an operator. So as our interpreter is going through our program and it's evaluating these expressions, we said earlier that this variable is a container, and we've named it n, and that n creates a symbolic link between this name here and the value that's in this container. So of course, when our interpreter goes to evaluate this expression of n, it's going to see this symbolic relationship, and it's going to evaluate that n as a 3. Now 7 is just a 7. So it's going to evaluate a value or a number as a number. And then in this combination of variable and value with an operator in the middle, it's going to see n, which is going to evaluate as whatever in this container. So it's got that symbolic relationship to the value that's inside of the container that is named n. So in this case, it's 3. So we could kind of swap that out and say 3 plus 7. So this would evaluate to 10. So all we're doing is we're finding the value of an expression through the process of evaluation. That's all that's going on here. So this is really quite a simple process that our interpreter is conducting here. And concatenation and repetition. So you can't perform math on strings. We talked briefly about what strings are. Strings are just a series of characters, letters, numbers, spaces, special symbols. They're given to us in a special way. So when we denote a string in a programming language, we put them in quotes. Where is my... When we denote a string in a programming language, we put them in quotes. And so what that does is that returns the ASCII value of the characters that are in between these quotes instead of the values that are, that might be the numerical value. So even if it's a number in between a set of quotes becomes the type of string and not the type of integer or just a number that you can do math with. So with numbers, you can do math. With strings, you can't do math. Because they're like words. And you really can't do math with words and letters. But we can still use some of our operators that we've discussed previously on strings. We discussed plus, minus, divide, and multiply. Now we can't use our divide. Can't use that. Or can't use our subtract, can't use our divide. But we can use our plus, and we can use our multiply on strings to do some different things with them than what we normally might experience with how we'd use those with numbers. Because in the last module you used Python as like a calculator, and you used these operators, and they did math for you. But we can't do math with strings, we've said. So the plus sign allows us to do something called concatenate. And so what this means is it means that we're joining strings by linking them end to end. And so we can only do this with strings. So if we want to concatenate something that's another type, like if we have something that is a value that we've been doing math on that we want to bring into this string, we do have to do type conversion on it. And we'll do that in our demonstration when we get there. But this just allows us to take different strings, different sentences, different bits of words, and put them together. The asterisk or multiplication symbol allows us to do repetition. For example, our example here is that we have spam asterisk 3. And that gives us on an output of spam, spam, spam. So it prints it out 3 times in a row. So it saves us a little bit of work. So that's pretty beneficial. One of the things that we want to do with code is we want to minimize how much we work. So if we can have shortcuts like this that kind of minimize how much we work, then that's even better. So I think that's my last slide for the day. It sure is. So I want to jump over to my programming environment now. So that I can start writing a sample program. And I want to write a sample program today that's going to be about finding the perimeter of a rectangle. So let's talk for a second about finding the perimeter of a rectangle and the things that we need to know. So you find the perimeter of a rectangle by adding all 4 sides. So we want to add all 4 sides. But we have a little benefit with a rectangle. We have a little benefit with a rectangle that helps us out a little bit when it comes to writing a program like this, and that's the fact that congruent sides or parallel sides are the same. So we only need two sides in our program. Then we could take those two sides, multiply each one of those two sides by 2, add the results of that together, and get our perimeter. So that's pretty good. So I'm going to zoom in here so you can... Oh, wrong key. I'm going to zoom in here so you can see a little better. And we're going to start out writing our program. And we need to start writing our program with the shebang. We talked about the shebang in the last live stream. We write the shebang to denote which version of Python that we're using, so that our users, or so that our interpreter is using the proper language to interpret all of the things that we've written. And so in this case, it's hashtag exclamation point / USR / bin, BIN / ENV space Python 3. We're working in Python 3. Remember that. So now we've added our shebang. So now whenever our interpreter goes to interpret our code, there'll be no question about what type of code this is. This is Python 3. Now the fact that it's in a Python 3 environment in our repo.it development environment is beside the point. We're getting into best practices, so we want to make sure that we're including that shebang. Because, you know, when you get on a system in the real world that is a development environment, you might have both versions of the language on there, and you want to make sure that you're including the right version of the language that you're working in. So we're working in Python 3. So now we want to declare our variables. And we've got 5 variables that I want to declare in this program where we're finding the perimeter of a rectangle. Now in this module, we're just going to go ahead and declare static values into our variables. In our next module, I believe it is, we're going to have a look at how we get inputs. So we'll change this up a little bit, starting with the next module. But for the time being, we're just going to assign static values to these variables. So we're going to assign side A and set that equal to, for right now, 12. And that's all we have to do to assign a variable in Python. Side B, and we're going to set that equal to 16. Simple, right? So now we're going to use our composition rule, and this is probably going a little overboard. We don't really need to do this because it's not data that we might need later. But just to kind of break down how we use composition, we break it down into small parts. So I'm going to go ahead and create a variable for each of the sides multiplied by 2. So that we have that step kind of broken down. Again, that's probably overkill for this program, but it's demonstrating an idea. So I'm going to do it. So I'm going to make something called side A x2, and I'm going to set that equal to side A times 2. So I don't have to put my value of 12 in there again, because I already assigned it to the variable of side A. And when I have that variable of side A, that creates the symbolic relationship between the name of side A and whatever value is inside of that container. So if I were to go back and change these values, right now it's 12, right now it's 11. or even 10, I only have to change the value of side A in one place, and that symbolic relationship between the variable name and the value that is placed inside of that variable carries that change forward. So it's the only place that I have to change it in the program. So it makes things a lot simpler on us. Side B, x2, equals side B times 2. Same thing there. And then finally something called perimeter. Then I'm going to set to side A, x2, plus side B, x2. And so again, the symbolic relationships carry the values forward. The interpreter evaluates the statement at that point, gets the value, pushes it forward, so on and so forth. So that's fine. And just to kind of show you what it looks like, I'm going to declare a string variable. So I'm going to create something called title, because we're going to have a little title of our program in here as well. And so I'm going to create a title, and I'm going to space perimeter of rectangle space. Now you might be wondering why I put these spaces at the beginning and the end. However you want it to look on the output is how you should put it on the input. It's going to look the exact same way. So I'm going to want mine to be formatted a little special kind of way. So I'm going to put these little spaces on the beginning and the end so it has some nice formatting to it. And that's going to give me the name of title. So now that I have those variables declared, I can start writing my program, or start printing out what I need to print out. Because really, I've done all the things that I need to do by now, like all the calculations that I need to do, and everything that I have to do to be able to find the perimeter of my rectangle is done, right? The only thing I have to do is print it out. And so here's where a lot of the other things that we discussed from the slides, this is where they're going to come into play as well. So we're going to add our if statement that we talked about last time. Our if name equals main. And this just allows this code to be executed if it's in the main part of the file. And again, just like we talked about last week, everything that goes under this part should be indented. 4 spaces or 1 tab if you're in an IDE. Because it's a part of this if statement. So the first thing that we're going to do is we're going to print out the title. We're going to print, and we're going to use that repetition character for strings. First, I thought that'd be kind of interesting to do instead of just typing out a colon a few times. Let's type out 1 colon and multiply it by 8. So I have 8 colons. 1, 2, 3, 4, 5, 6, 7, 8. So that'll give me 8 colons on my output, just to give me a nice little decoration around my title. So then I can concatenate that with my title variable. And that'll and because of that symbolic relationship, that'll go and find that container name, take the value out of that container and bring it back and put it in there. It creates that relationship between the name of that container and the value that's in that container. And we're going to concatenate that with, I think I'm going to do this again. this colon multiplied by 8, just so we can have 8 colons side by side by side by side by side. And we can actually go ahead and run this and test it really quickly if you wanted to try that out. So I'm going to click run and jump over to my output, and you can see that's the output that we're expecting right there. 8 colons, perimeter of a rectangle, then 8 more colons. Just to give us kind of a little title to the top of our program. Pretty neat looking. Next, I want just an empty line. So I'm just going to put an empty print statement there. And that'll give me an empty line. That way I can have a blank space between the title of my program and the information that's coming next. So now I want to output my information. So I'm going to print length of side A. And I can concatenate that with side A. And I can concatenate that with units. And that's a space units again, because you want your string to be kind of spaced out and formatted the way you want it to look. So since I want a space between my number and the next word, which is units, I have to put that space in there. Remember that your computer is kind of dumb, doesn't really know what you're talking about. You have to tell it what you're talking about. But now I also said that we can't concatenate with numbers. This is going to run us a little bit of a problem because that side A is a number. So let's see what happens when we try to run this really quickly. Throws us an error. And we can read this error and we can get information out of it. File main.py, so it tells us what file it's in. On line 16, and then it tells us which line it has a problem with. Can only concatenate string, not integer, to string. So in this case, we have to do a little bit of type conversion. So in Python, we do it like this. We take what we want to convert. In this case, it's an integer that we're converting to string. So that's str. And then we wrap what we want to convert right after it in parentheses. So it's an str function that we wrap our integer into. So now when we run that, we get length of side A 10 units. Which is exactly what we're looking for. So now I can copy this line, paste this line, and in the pasted line I can change references from side A to side B. And I can run that. Make sure that works. Length of side B, 16 units. Good. And so finally, I can print out the perimeter. Print perimeter of the rectangle. Concatenate that. Since the perimeter is also going to be a number, I'm going to want to do string conversion on it. And that's the perimeter variable. Just like that. So now when I run my program, I get that. Perimeter of a rectangle, length of side A, 10 units, length of side B, 16 units. Perimeter of the rectangle, 52 units, which is exactly what we expect. Like, we can do the math. This one's simple enough that we can do the math in our head and figure out that, like, yep, that's correct. We did it right. And we can kind of move on. Like, we can say, okay, 10 plus 10 is 20, 16 plus 16 is 32, 20 plus 32 is 52. So the perimeter should be 52, so we got it right. And so now if we want to do something different, like if we want to come back in here and change these numbers, we just have to change them in our side A and side B variables. And even if we want to do something that uses some kind of floating point number, we can do that as well. Since Python's not strictly typed, we can go ahead and just put a floating point number directly in there without having to do anything fancy and get out exactly what we would be expecting from our problem. So it's been about 30 minutes, and that's as long as I want to go on these live streams. So that's where we're going to stop for today. I'm going to go ahead and turn the music back on for just a few minutes and hang out in the chat, just in case anybody has any questions. If you have any questions, feel free to send me an email. And when I say if you have any questions, I mean you. If anybody's out there watching this later has any questions in the course, feel free to send me an email, and I will answer your question. But again, that's all that I have for you for today. Thank you for watching, and we'll see you next time.